Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. In the lecture series of Material Studio, and within the course of hydrogen storage, we are at the lecture number 2. And in today's lecture, we will explore further the particular perovskite material which we discussed in our very first lecture. So, basically to check whether the material is capable for hydrogen storage or not. We must check the other related properties, like whether the material is a semiconductor, insulator, or metal. So also we will check the absorbance, like optical absorption, optical spectra, dielectric function, and we will also check the contribution. In our case, we have X₂MH₆. We must check the contribution of A element, M element, and H element as well. So for this, we have to explore some additional properties. Like for example, just to check the gravimetric capacity or volumetric capacity, one can understand whether the material is hydrogen capable for hydrogen storage or not. But to fully explore the material, we have to check some other parameter. I mean, we have to explore the electronic properties, the optical properties, the elastic properties, and we will also do some vibrational analysis for the sake of stability, whether the material, the most important thing is that we have to check whether the material is thermodynamically, dynamically, or elastically stable or not. So for this, we have to calculate, we have to do some other calculation, and that series today is our second lecture. And in today's lecture, we will learn about the band structure, and on the basis of this calculation, we will then finalize whether the material is a semiconductor, insulator, or metal. So for this, as we already know how to do geometric optimization, and we learn about the function, how to set function, how to set qualities, and the cutoff energy and the K points as well. So this is our optimized structure. We already upload one lecture on our YouTube channel. So we will start from here. We will must calculate the properties. We will must do geometric optimization at first, and then we will use this optimized structure to calculate the properties of material. So in the property series today, and in today's lecture, we will learn how to calculate band structure. Okay, so this is our optimized structure. Let's move ahead towards the screen, and first we should open the optimized structure, and then we will set the calculation parameters. So it's very simple, and keep in mind we are restricted. We will not change the calculation parameter. We will use same to same like we use for geometry optimization. We will just change the task section, and we will select the particular property tab from the property section to which we want to calculate. Like for example, if you want to calculate band structure, then you should select band structure, and if you want to calculate the density of state or optical properties, then you should select that particular property, that particular tab from the property section. But no need to change anything else, like no need to disturb the quality, function, and the cutoff energy and K point as well. We will must use these properties same these setup same to same as we use like for geometric optimization. So our task is to do properties calculations. So we will must select properties from here, from the task section, and then as I told you, no need to change anything else. Like for example, if you geometrically optimize the structure with the generalized gradient approximation within a PBE function, then you should go with the same. No need to change. Okay, if you for example make some changes, then there is a possibility that maybe the results should be fluctuate. So we will not change the cutoff energy and K point. Also the CD potential, we will go with the same as I told. Same like here. Nothing would be changed while doing properties calculations. So we will just make changes in properties tab. Since I already calculate the band structure, so that's why the tab is take out. So you should take out this, okay? And let me repeat it again. At first you should open the optimized structure. This is optimized structure, okay? You should open the optimized structure, and then from the task section you should select properties, and within the properties section you should select band structure, okay? After that we'll run the calculation, and after some time, like 7, 8, 10 minutes or 20 minutes, or maybe sometime it take hour to calculate band structure. So and then you will get results, okay? So once the calculation is completed, the next step, you know, the DFT calculation is in within 3 steps. The first step is to make model, the second step is to do DFT calculation, and the third step is to make analysis. So we successfully design our perovskite material, which is on the screen, and we also complete the second step. We perform DFT calculation. We make geometry optimization, and then we calculate band structure. And now we are at third point. At the third steps. So we have to make analysis. So for this, you should open the output file of band structure. This is the output file for band structure, and then open the CASTEP module. And instead of selecting calculation, we should go with analysis step, okay? And here since we perform calculation for band structure, so we should select band structure while doing analysis, okay? And just simply click on view. We will see our results. This is our calculation with GGA PBE. There is a possibility if we change make some changes in function, like if we do calculation with hybrid, maybe the band gap leads to 2 electron volt, or somehow 2.10 or 2.20 electron volt. But with GGA PBE, this is our band structure. So you see there is a very clear gap. So it's mean the material under observation is semiconductor with a band gap 1.164 electron volt. But keep in mind, this is with GGA PBE, okay? If we use some hybrid function, there is a possibility maybe the band gap increase to 2 electron volt, or maybe to 2.10, 2.20, or somehow. So this is how you calculate band structure while studying hydrogen storage. So with this, thank you very much. Yes, we will explore further properties in upcoming lectures. If anyone have any question, please feel free to ask. I will answer definitely, and stay connected for further lecture. Thank you so much.